Hello all and welcome to GW Prime Live. Your where is here. Today we will be talking about technology interventions in DFMA, workflows and precision engineering. I am Titash Roy, Industry Manager Infrastructure of Geospatial World, and we have an eminent guest amongst us today to discuss about the concepts of DFMA workflows, precision engineering and the role of different digital technologies in these respective workflows. Before I introduce our guest for today, let me make a small attempt to throw some light on DFMA. So DFMA, an acronym for Design for Manufacture and Assembly, can be regarded as a combination of two methodologies: design for manufacture, which means the design for ease of manufacture of the parts that will form a product, and design for assembly, which means the design of the product for ease of assembly, deriving creative ideas at the same time. So DFMA within the ACE industry, it does open up possibilities for addressing the skilled labor shortage, delivering data-driven designs informed by manufacturing and process intelligence. The practice of applying DFMA is to identify, quantify, and eliminate waste or inefficiency. So I believe it is quite safe to say that DFMA is a component of lean and resilient construction. So in this context, and without further ado, let me introduce our guest for today, Mr. Gary Cowan. Gary is the head of digital construction at a multidisciplinary building service contractor company called Kane Group, which is headquartered in Northern Ireland. Welcome to GW Prime Live, Gary. How are you?
I'm very well, thank you, Titash. Thank you for having me today.
Welcome. Gary is a highly skilled and experienced digital construction specialist. With 18 years of experience in the construction industry, he's recognized as a global thought leader in digital construction and has proven a track record proven track record of delivering successful projects. Gary has a deep understanding of the construction industry, the methods of implementation of advanced BIM and VDC, enabling DFMA processes and MMC. He's passionate about using cutting-edge digital tools to push innovation and drive improvements in efficiency and sustainability in construction. He has a bachelor's degree in mechanical and manufacturing engineering from Queen's University, Belfast. He began his career in the construction industry as a CAD technician before moving on to site-based construction management, before returning to specialize in large-scale MEP coordination. He now leads an award-winning team within Kane Group, pushing the boundaries of digital construction, always exploring new ways to integrate new technologies into the construction process. I'm really glad to have you with us today, and thank you for taking out time for us on a weekday. Really appreciate this a lot. So I know we'll start with the discussion, but before we jump into the questions, I would like the definition of DFMA from you. So the stage is yours now.
Thank you very much. DFMA is quite a new term and process that's been introduced to the industry in the last few years, and really the concept is for the building itself to be treated much like any component that would be manufactured in a factory, to try to remove as much of the work from the site as possible to a factory control setting where things like material wastage and quality can be looked at, at a much more finer level, and the end product becomes sort of much more streamlined, and it transfers quite a lot of the work from the building site to a factory, and then it allows kind of parallel processing of work so that the traditional linear sequence of build can kind of be attacked from a parallel stance, that the building services can be designed and fabricated off-site in line with the building being built, and we don't necessarily have to wait for a particular point in time for the building to be ready to start a traditional build. So it's really trying to build a building from a manufacturing point of view rather than a traditional builder's point of view.
Right. Thank you for simplifying the definition. So my first question will be regarding the workflow itself. How is it? I'd really like to understand how it is different from a traditional construction workflow.
Well, traditional construction would have initially started with concept sketches, and quite a lot of the coordination of complex building services traditionally used to happen live on site. It was down to the men and women on the ground who were installing the services to really understand the concept design from a a drafts person as it was back in the day. They used to sort of draw two-dimensional AutoCAD general routes of services, and it really was down to the talent on the ground to make that concept a reality. But the difference with DFMA is that there's really early integration and collaboration between the design teams and the construction teams. In reality, the earlier those two can come together, the better, and it allows sort of the built-in services and the complex sort of areas to be looked at relatively early in the design, and that can be kind of developed in parallel with the rest of the project, and not being left to sort of 10 plumbers and 10 sparks landed on a site with very rough drawings and all of the materials in containers. It streamlines the whole process. It sort of allows prefabrication and considerations of pre-designed stuff, and it massively promotes efficiency and waste reduction. There's so much less waste involved because it's very precise designs, very precise shop drawings, where we're not kind of second guessing runs or having to go back and alter layouts. That clashes kind of have been eradicated now, all of the clashes are found in a virtual model now, rather than any plumbers or ductmen running into each other on site and having to down tools to take time to figure out the clash on site. It just streamlines the entire process, and overall the benefit of it is a much higher production of quality. Then our QA on site, we've noticed a big change, that quite a lot of the stuff is coming from the factory correct, so that the QA on site becomes a much quicker process as well.
Right. Thank you. Thank you for breaking down the workflow. And so I believe from what you said, it's the starting point is kind of the design part of it, and and the end part of this workflow can be the assembly part of it. So if you can, if you can now connect the different digital construction technologies, and we will explore the different technologies, later, like how it is essential for this supporting this workflow. But right now, if you can give a little bit of a brief about what are the different technologies that are really essential for supporting this workflow.
Yeah, well, obviously, if you have your BIM authoring tools, are first and foremost the place where all of the three-dimensional modeling happens. So most people use Revit in the industry. So the architect will use Revit, and the structural engineers will use Revit, and we federate all of their models together to give us a conceptual building in its full entirety in 3D. And then we would go inside that and sort of survey the entire model and figure out exactly all of the routes and positions of major plant, and we really analyze the design to see how can we modularize this layout, how can we break this into sort of, how can we prefab if there's big long corridors with lots of pipes and ducts and cable trays. We will look at that and see how we can break that into a modularized system to be able to develop individual modules. And that kind of works in parallel with the design, with the structural engineer and the architect. We work with them to make sure that the loadings on the buildings are correct. We're not clashing with any ceilings and access. So that's all developed in tandem with those guys through stage 3 into stage 4. And then once we hit stage 5 and the design goes to, we're about to push the button, generally we would use reality capture technology. We would send our guys onto site with the Leica or BLK G2, and we would point cloud capture the structure that has been created. The reason for this then is that we feed this point cloud back into the Revit ecosystem, and that lets us do a visual verification of the actual building, so that kind of removes the element of surprise and removes building tolerance. So any adjustments that have to be made to the Revit model prior to fabrication can be captured at that point. So if there's been any differences in the fabrication of the building, or holes have been formed slightly off center, or that allows us that final sort of adjustment prior to pressing the button and sending everything out to the factory to get fabricated. And then generally it comes to site prefabricated. And then we use another technology that we developed in conjunction with Leica for a precision setting out system. So we use the precision sort of topographical survey equipment on site to be able to precisely pinpoint certain coordinates on the site. So we would place coordinates in the 3D model at particular points for, say, anchor points for a frame, or the four corners of a piece of kit that sits on the ground. And that allows us to position the stuff in real world very, very quickly, very, very accurately. And then that further complements the DFMA process because all of the interlinking pieces that would join all of these can then also be prefabricated, whereas traditionally that would have been a site measure and a site fabrication in situ because of the uncertainty of the building tolerance. There are certain things now that can be prefabricated well ahead of time, and the whole process of building our models on site really does boil down to a huge Lego set with detailed instructions that is generated from the BIM and CAD teams.
Right. Thank you.
And then when finished, we use the reality capture technology to verify that it was actually installed in the correct position. And if there's any final sort of tweaks to the model, then the model can be adjusted at the very, very end. And that lets us provide a uniquely accurate digital twin to our clients then to pass on to their FM teams.
Right. So it's quite evident that a lot of technologies are kind of involved and kind of essential for a successful implementation of a DFMA project. Coming to the benefits, so I remember I kind of got to know about this prefabrication and DFMA, and I got a bit passionate about this subject sometime during the COVID times, the early 2020s, because this pandemic, when it hit the world, it no one was prepared for it. So one of the thing I remember that there were some few examples that we read about at that time was from China. Some of these hospitals that were constructed within like hours, not even like a day, and fully functional and operating hospitals. So I'm pretty sure that enhancing the project delivery is one of the greatest benefits that prefab, DFMA, these type of construction projects can do. But what are the other key benefits that that are there when you're implementing DFMA in construction projects? If you can shed some light on that.
Yeah, well, as you said, Tash, the primary one is time. It allows parallel design and parallel construction to happen. So it kind of reduces the traditional linear path of a construction site, and it really allows us to attack really aggressive timelines in projects, and a lot of our clients sort of see the benefit from that we can kind of work in tandem with them, and we use a sort of the just-in-time and lean principles to control sort of materials to site. So the site logistics becomes a lot easier as well, because you're not actually handling as much materials on site and trying to store materials and move materials. Everything's coming from the factory, sort of programmed and scheduled along with the program, so that it's just in time. A frame or a rig will arrive days before it's actually due to be placed in the site, so that it reduces the requirement for site storage. It reduces the logistics and the carbon footprint of the company, because we can manage our sort of material deliveries much better and avail of sort of better workflows. We have a London warehouse, we have a warehouse here in Northern Ireland. We can sort of hold stock and get much better cost savings on materials for the people involved in the construction. It removes bodies from site. So whereas people would have had to work on quite dangerous building sites, now a lot of our people are actually in a factory setting where the welfare amenities for them are much better. They're working in a controlled temperature environment. The safety aspect, they're much more safe in a factory. They're not going to get hurt or injured on the site at the same level of risk. And it means that for the guys on site, it's much less footfall on site, which benefits our end clients, because there's not so many plumbers and sparks running about. It's much more of a sort of general labourer can put these things together, and it's only the final fixes where the professional guys come in and the plumbers come in and do the final fixes and sparks. So it allows us to sort of increase the speed at which we can build these buildings.
Right. Thank you. So I believe there are many folds of these benefits. Quickly jumping into the challenges part, because this is something which is very different from the traditional construction workflow. So are there any challenges that you faced, in terms of the implementation of these kind of workflows in your construction projects? Your views on that?
Yeah, well, I mean, just a cultural resistance really is the first thing. Trying to get people to adopt to a new workflow and a new way of thinking can be difficult. I'm very fortunate that in Kane, our owners and directors are very forward thinking and really look at new technology as soon as it's available. So I'm fortunate that they've sort of trusted me to implement quite a lot of these new technologies and test these, and even in the first place, because obviously there is a huge cost implication with looking at these technologies. We've been building our digital team and our digital workflows and processes for over sort of 12, 13 years now from I started. So it's been very long going. So there's huge costs for both sort of the technologies and the licenses and the equipment and the hardware, the PCs, VR headsets, all the technology on site from iPads to sort of, there's a huge cost implication as well that a lot of companies wouldn't necessarily see the benefit from, or they sort of don't see the wood for the trees, as the saying is, the sort of bulk at the cost of implementing this system, and not look at it as a 5 or 10 year plan of how much money then they would actually save with this digital workflow and digital processes. That would be a sort of the major linchpin for quite a lot of them. And then just the actual complexity of it in itself. You have to master 10, 15 different software packages, and you're dealing with sort of authoring tools and visualization tools and error checking tools, and it's hard for any company and any one person to be able to master all of that. So finding the people is also an issue, and that maybe some of the universities and colleges here in the UK actually aren't providing the level of training and the level of experience that we actually need in the industry. And that's kind of why I kind of do STEM events, and I'm a STEM ambassador, so I would actively go and speak to the universities and the colleges and try and feed back from an industry perspective what these people, what the young guys and girls coming behind us need to be able to succeed.
Right. So capacity development was one of the biggest challenges, I would presume then.
Yeah, really is. Yeah.
Right.
And just having everybody in the industry working, because we can be sort of very close to the crest of the wave in terms of technological advancements, but you're working with other design team members that maybe a lot of architects we work with would still tend to want to work in 2D CAD, and interoperability between systems in itself is a really big challenge as well. You've got steel guys working in Tekla, you've got architects working in ArchiCAD, you've got MEP guys working in Revit, and you've got civil guys working in Civil 3D. And how you get all these software systems to talk to each other and maintain all of the correct GIS coordinate systems is very complex in itself as well.
Right. That was really insightful, Gary. So I know, let's quickly move into the other part of the topic today, which is the precision engineering part. So how does that complement DFMA in the construction sector? I believe it does play a role in enhancing the construction quality, reducing errors and clash detections, those kind of stuff. But some other things that you would like to put some light on. So yeah.
Well, the precision engineering part of it is essential to the whole process. It's impossible to design anything for assembly if it isn't exactly precise. My degree, as you said before, is in manufacturing engineering. I didn't do a degree in BIM. I'm of the age now when I did my degree, BIM didn't exist. So I really applied the principles of my degree of actually designing components over into the actual building. Whenever I decided to become a building services engineer, I treated it just like one massive machine that I had to sort of detail out and draw in immense detail. And at the time in the industry, that was unheard of. People were using Revit very, very loosely and very sort of roughly. And I was a very early proponent for hyper granular BIM modules where every small detail is captured. And reality is that, in today's technologies and how it's worked now, it's essential for sort of streamlining bill of quantities, material takeoffs, visualization for our clients. We're using the gaming engines, we're looking at Unreal Engine and Twinmotion, where we're doing beautiful renderings for marketing and purpose. So, the BIM is at the core of it all. The BIM model and the authoring tool is kind of the center sun of the ecosystem, which would be the solar system, and it can branch off into all aspects of the business, from procurement to estimation to operations and design. It touches every part of the business now, where when we first took it on 10 years ago, it was kind of a tick box exercise for a particular project, but it's hugely important within the business now.
Right. So you mentioned about BIM, but I would like to understand more on the digital twins part. How does that technology kind of integrate with these processes? What is the scope for digital twin in the FMA precision engineering?
suppose the digital twin is when this static model takes life. Once the building is active and on, digital twin technology really encompasses the Internet of Things. We would hope that all of the live systems that we have installed in the building, such as the building maintenance system and or the fire system and all that, can be smartly connected to the facilities management team that ultimately will take over this. So, they will have a full, highly accurate model that they can sort of traverse through and review remotely without having to physically sort of appear on site. And then all of the support and documentation in O&Ms is all digitized now. So in the olden days, the FM guys would have got a huge lever arch folder with all of the paper drawings and paper printouts of all of the technical documents that was involved. And now that's all digital. So if you go into any one of our models and click on a particular piece of equipment, there will be all of the metadata built in that has all of the O&M data, web links to take you to external resources to get all of the sort of FM data that would be required and how to maintain particular pieces of kit. And then that also lets them schedule them and sort of have a computerized, digitized tracking system so that they know that a particular piece of kit needs to have a maintenance engineer attend perhaps once or twice a year to perform critical maintenance procedures, and that ensures that any critical systems in any of the buildings that we're providing, like life safety systems within schools and hospitals, don't be overlooked and aren't at a danger of failing.
Right. Gary, earlier during our chat, you also, like when we were listing down the different technologies which are essential for these workflows, you did mention about robotics, automation, and especially AR and VR. So these are again some of the technologies that I'm really interested to know more. So maybe you can start with robotics and automation, and then we move on to the VR AR aspect of it.
Yeah, I mean, robotics we're starting to see appear in the industry now too. In our fabrication shed, we're currently looking at robotic welding machines and robotic machines for automatic cutting of sort of steel sections. And the initial sort of look at this is a marked leap in output and quality because the welds are automatic and it's been done by a machine. So the welds come out perfect every time, and it drastically reduces the amount of sort of man hours that are involved in producing large scale sort of welded flanges and steelworks. So we're really seeing that immediately within the company. Other robotics that I've seen out in the field, obviously we've seen the sort of all the different Boston Dynamics robots. The Spot Dog is starting to appear. I know Balfour Beatty in the UK were one of the earliest people to bring it on. Particularly, we were doing a job with them, and we were sort of shown the technology of the dog walking around the site with a point cloud scanner on its back, and that was programmed to walk the site sequentially once or twice a week and capture the point cloud data and also register it with AI and send it to the cloud. So they had sort of automated that entire process of a continual point cloud scan appearing every week, which then could be compared against the BIM model to give them a precise project report or a progress report, should I say, from a digital sense, and that it didn't require a human to go and walk around the site and give a sort of very guesstimate on percentage completion that the QSs would use. So, I've seen automation creep into that aspect of it as well. It's a quite exciting thing. And also the precision setting out of the HP SitePrint robot that kind of marks out all of the floor tracks for the walls on the floor. So it's guided by the topography, the top station, and it's able to print the floor plan on the screed so that then the guys can go in, and again, it's just connect the dots. And it's all about efficiency and speeding up processes on site.
Right. And you did mention about AI, so that is another interesting piece of technology which is kind of getting implemented across different sectors, and construction sector is also part of that. So how much of an integration of AI has been there in your workflow, and by your workflow I mean the Kane Group's workflow, and how do you see the impact of AI changing over the next few years, maybe say a timeline of 5 years? What's your take on this?
Well, AI is quite still in its infancy. I know it's a real big buzzword in the industry at the moment, but at the actual coalface, the reality is that a lot of companies are quite hesitant to use it for obvious reasons. We have been experimenting very lightly with some of the Revit-based AI engines, like Evolve Lab. I have a Glyph add-in that I was sort of given better access to, so it kind of speeds up some of the workflows within Revit for automation of elevation creation and view and sheet creation. So rather than a technician spending a lot of time creating views and sheets, they can simply chat to Revit, and Revit understands from their conversation what it is that's required, and it can automate quite a lot of the processes. So we're sort of experimenting with it. But in reality, I kind of see AI becoming a real complementary sort of assistant for a lot of the tools that we use. So for example, point cloud registration and data sort of management, I would hope that in time to come that would become completely automated, that once the data leaves the scanner, it is automatically registered, automatically cleaned, and set into a particular folder for use. That would remove quite a lot of man hours that we use at the moment. And also, I would hope that we could sort of look at AI to help our document control team, who have to check up to 500 drawings a month that would leave our design team. So hopefully we could look at AI to see if there's a way of given specific rules for, say, an apartment layout, that each room has to have a minimum of 2 sockets, and we expect to see in our terminal, and it would be able to check the drawing and report back with a list of drawings that have things that are missed or mistakes that would take a human quite a lot of time to do, and hopefully the AI would be able to perform that check in seconds or minutes or hours, compared to weeks of man hours. So I do see AI becoming an augmented tool for humans, but it'll still have to have a human driver. I do hear a lot of talk of people saying that AI is going to replace a built-in services engineer or an architect, and I don't honestly think that's the case.
Right. Indeed, I think AI is one of the most splendid emerging trends we see in this construction sector. Do you want to add something on these? When we are talking about emerging trends, do you see some other emerging trends that you kind of foresee in the DFMA workflow over the next few years?
Yeah, I mean, one of the sort of things I've been involved in for quite a number of years now is sort of XR technologies and using virtual and augmented reality in construction. We were a very early adopter of VR when we were doing our Claridge's project back in 2016. That job was a complete prefabrication job, and that everything had to be prefabricated. So the only real way to properly inspect a model of that magnitude and density is actually from the inside out. So the VR system allows you to export the model to a VR environment where you can slip a headset on and you can virtually site walk the site and raise issues, markups, all that kind of thing. And that has been available for a while, but it's really only coming to the forefront in the industry in the last year. I was over in Las Vegas at AU 2024 last year, helping Autodesk launch their Workshop XR, which I've kind of been feeding them guys our models to make sure that the system was able to take a hyper granular model. And the leaps and bounds that's been happening on some of the technologies. There's another package called Resolve that has been released there, which is a phenomenal VR system, and that it can render the entire building. And the Workshop XR is following very closely behind in terms of scalability, and it's amazing where the VRs came from. From I started in 2016, it was very limited to very small areas of the model, whereas now these engines and the technologies are sufficient enough that we can render full buildings and entire sort of neighborhoods, looking at all of our services in minute detail. And then the natural progression for that is augmented reality, so that when the guys and girls appear on site and there's boots on the ground, they can use iPads to sort of see a hologram or a holo view of our BIM model in context with the skeleton of the building, and highlight issues with design or coordination at a really early stage, long before we would ever be on site with installers. So I see XR, mixed reality, being a real thing that's going to be normal in the next 5 to 10 years. I expect to see people walking around sites with mixed reality headsets on that are able to convey all the data required for the installation, while at the same time using the inside-out tracking system to make the users aware of dangers around them, perhaps giving you a heads up that there's a approaching piece of Kittler machinery. I think that's going to revolutionize construction.
Right. Thank you. I believe we are nearing the end of this discussion. I wish we had some more time, but before we sign off for today, I would really like to touch upon a couple of more facts. So it's quite evident that this construction industry is gifted with a very seamless kind of a workflow through these integration of DFMA and precision engineering into this. But what role do you see that the national level policies and the mandates play to ensure this seamlessness of this workflow?
I think the sort of the attitude of any nation needs to be to have certain policies and mandates in place to push this technology and push this type of workflow. Um, it suits everyone that's involved. It suits all of the contractors because lean, efficient processes are cost efficient processes. So it doesn't go; they go hand in hand, and it's really important that it is placed inside standards because it establishes clear standards for everyone involved, that everyone is bringing the same quality of workmanship to the table. It gives incentives to all of the companies involved. They have to pull their socks up and they have to get to a certain level of design. And then it also sort of helps in the training program aspects. It opens up sort of avenues of talk between the educational institutions and industry as well, and make sure that the right people are being taught the right things for the industry.
Right. So before we sign off, Gary, would you like to not showcase, kind of share a few of the successful case studies that you have, the names of it, maybe what the project was and what type of ROI you got because of this DFMA workflow? It will be really nice for us as well as the audience, I believe. So, yeah.
Yeah, I mean, if you were to go to our website, obviously www.kanegroup.co.uk, you'll see a long list of case studies that we have on our website of really successful projects that we've delivered for our clients. Probably the most notable one would have been the Claridge's Hotel in London that we delivered for our client, the Mayborn Group, back in 2019, 2020. It was an amazing project to be involved in. They sort of excavated below the existing hotel and constructed a 6-story concrete substructure that we then were sort of appointed to provide all of the building services here. It was a hugely complex logistical project. There was no site storage. There was no sort of use of anything other than one centralized shaft. So everything that had to be sort of delivered to site had to go down the shaft. So everything that was designed had a real constraint on geometry. So all of the prefabricated systems for large bore, sort of 10, 12-inch pipework had to be constructed in frames that could sort of be lowered down the shaft and then moved to position and installed very, very rapidly due to the scheduling and the sort of constraints on logistics. So it's where all of our digital tools were developed really for precision setting out and precision modeling within Revit. It really drove all of our technological advances. So it was kind of the test bed for my ideas for all how to produce coordinates from models and how to translate digital systems. And it kind of was a baptism of fire because we did it live while we were doing the job. And then when we learned all the lessons from those systems, we then figured out a way to translate that across to all of our projects, no matter if they were industrial or residential or commercial. So it sort of accelerated workflows and accelerated sort of considerations. And it was really a transfer of sort of knowledge from the site guys over to the design team and the coordination team. So we worked very hard to build a digital team here in Northern Ireland, and we have really highly skilled BIM technicians that work for us, a team of about 12 or 14 at the moment, and they're the best in the business, really, I think. So it's great to have them.
Right. Thank you, Gary, and congratulations on the work that you're doing, and all the best for your future endeavors with Kane Group. We really look forward to looking towards more of these case studies. I'll personally go visit the website and gather some more knowledge on this. And thank you again for joining us, clearing our misconceptions about DFMA, about precision engineering. We touched upon the challenges, the benefits of these workflows. We talked about the different convergence of technologies and what is the role that they are playing in bettering this workflow. Your take on the national policy, and how it is going to help help this workflow in the future. I think it was quite a insightful discussion for us as well as the audience members, and I really enjoyed this a lot. I really hope that our audience also did. We look forward to converse more with you in the future, and look forward to bring your insights on the industry through future collaborations. It was a real pleasure hosting you today at GW Prime Live, and thank you again, for giving us your time.
Thank you very much, Titesh. The pleasure was mine.